All right, so today what we're going to do is we're going to solve equations. We're going to start with something called one-step equations, and then we're going to build up to harder equations over the next couple lessons. Before we actually get started, we're going to talk about what an equation is. So an equation is basically anything with an equal sign. So anything with an equal sign is essentially an equation. Typically, we have letters and numbers. So something like this down here is an equation. We have x plus 5 equals 2x minus 8. If there was no equal sign, it would look just something like this, x plus 5, or something like this, 2x minus 8. We call those expressions. Awesome. To solve an equation, it's a phrase you're going to hear a lot. So, solving an equation. I say it means to figure out the value of your variable, to find a value for your variable. Remember, a variable is like a letter. So essentially, if you were to look at this equation right here, solving that equation would mean finding a value for x that makes this equation true. It makes x plus 5 and 2x minus 8 actually both equal each other. So, for instance, if we pretended that this equation right there, that the value of x was equal to 13. Sorry. Yeah, so we pretend it's x equals 13. What you would have is you would have an expression that is now equal to another expression. So for instance, if we pretend this is 13 now, 13 plus 5 is equal to 18. And if you were to try the other side, 2 times 13 minus 8 is equal to 18. And what we did was we found a value of x that made this actually true, where both sides really are equal to each other. So that's what we're going to do today. We're going to find values of x that make equations true. The way that we do that is by getting a variable by itself. I like to use the proper terminology is isolating the variable on one side of the equation. The phrase that I like to use is get x, or whatever letter we're using, by itself. It means the same thing. It means to isolate. We're going to do several questions where we see things like that. We've actually done a little bit of this. I called it algebra in previous units. So we've done algebra like this before where we've rearranged equations. It's essentially what we're going to do today, except we're just going to be rearranging so that a letter is completely by itself and numbers are on the other side of the equal sign. So for instance, if we look at this first question right here, I have an equation. I know it's an equation because there's an equal sign. I want to solve that equation. To solve means to get m, in this case, by itself, so that I actually have a value for m. Our strategy for getting a letter by itself is to do BEDMAS, but in reverse. And then we're going to do something else called opposite operations. So my goal, when I look at this equation, is to somehow get m on one side of the equal sign all by itself. Currently, I have a plus 5 that is being attached to that m. I need to move that plus 5 to the other side. The way that I move something is by doing the opposite operation to it. So if I wanted to move that 5 to the other side, instead of plusing 5, I need to minus 5. And that would cancel itself out and get rid of the 5. But in math, what we do to one side, we always do to the other, right? These things have to equal each other. So since I had to subtract 5 from the left side, the only way to keep the other side equal is to also minus 5 from it. That means I now have only m on the left side of the equal sign, and then 9 minus 5 is 4. This means my solution is m equals 4. I know that's true because if I went back to my original equation was m plus 5 equals 9. I could verify that my answer is correct by changing m to be 4 and then seeing if it actually did work. So 4 plus 5 is 9. 9 does actually equal 9. That means I was correct. M equals 4 is the right answer. Awesome. If we look at B, I want to get h by itself. Currently, I can't get h by itself because it has this minus 7 attached to it on that side of the equal sign. So to get rid of minus 7, I do opposite operations. The opposite of minusing is adding, so I'm going to add 7. And what I do to one side, I must do to the other. 7 and 7 would cancel out because one was negative and one was positive, leaving me with h on the left side. On the right side, negative 9 plus 7 is negative 2. So my solution is h equals negative 2. Now, I've prematurely mentioned that we need to utilize BEDMAS. We actually don't have to worry too much about BEDMAS today. But if you had multiple numbers attached to your letter, you have to move things in a certain order, and you move them in the order of BEDMAS, but backwards. So we actually move additions and subtractions first, and then multiplication and division next. We won't be doing that until our next couple lessons. So I prematurely talked about BEDMAS in reverse. All we have to worry about today is opposite operations. All right, if you look at C, my goal is to figure out what W equals. So I have to get W by itself. To do that, I need to move the minus 14. I do that by doing the opposite of plus 14, which would be minus 14. And what I do to one side, I do to the other. That leaves me with W equals negative 8 minus 14 is negative 22. W equals negative 22. If I look at D, X is now on the other side of the equal sign. I need to try to get it by itself. To do that, I have to somehow move this minus 1.1. The opposite of minusing is adding. So I need to add 1.1 to both sides. That will cancel out on the right. 2 plus 3 plus 1.1 is 3.4 equals, and then on the right side of the equal sign, I have an X. So 3.4 equals X. Awesome. That's getting rid of additions and subtractions. We can also solve equations using algebra tiles. Again, algebra tiles are super limited, so you will notice I'm not like the biggest fan of them in the world. But the idea here is that we want to figure out what 1x is worth. So that would be what a long skinny tile is worth. The way we do that is by looking at these algebra tiles and trying to eliminate everything down to just one x tile. So if I look, I could basically cancel out 1 for 1 with these little tiles. And I'm left with one tile, which is x, equals 3. This would mean x equals 3. Cool. If you look at the second one, we can't really cancel them out because these are negatives, right? So this is the same thing as saying x and then minus 2 equals 4. So this time we can't cancel things out because they're not the same. So I somehow have to move these tiles to the other side. The way I'd move them to the other side is by adding 2 tiles that are positive to both sides, because then these tiles would cancel each other out, and I would be left with 1 long skinny x equals 6 individual tiles. The application of algebra tiles is super limited, just like it was in our previous units, so you won't see me do it a lot. It's just sometimes it helps people visualize what's going on with math when they have algebra tiles. So that's why we mix in a few questions. Awesome. Example 3. So again, we're going to try to solve the equation. I know these are equations because there's an equal sign, right? I'm going to solve them, which means get the letter by itself. Like figure what the value of that letter must be. If I look at A, my goal is to get M by itself. I can't get M by itself right now because there's a 3 next to it. Just a reminder that this, if there's no symbol in between the variable and the coefficient, that means that that is multiplication. So that is really 3 times M equals 2.1. I know we've talked about that lots, but it's important that we remember that if there's nothing in between a number and a letter, it's multiplication. If I want to somehow get rid of that 3, I need to do the opposite operation. If it's being multiplied, the opposite of multiplication is division. So I'm going to divide by 3. And when I divide by 3, those 3's will cancel out. But what I do to one side, I have to do to the other. So I also have to do 2.1 divided by 3. We're just going to do that with our calculator. So it's going to be a decimal, and that's okay. We're going to 2.1 divided by 3. And we're going to get an M value of 0.7. Awesome. Let's look at B. So if I want to solve that, I want to get B by itself. I have to do opposite operations. That's 4 times B, so I need to divide both sides by 4. On the left side, the 4's will cancel, and I will only have a B left over. On the right-hand side, negative 20 divided by 4 is negative 5. That means B equals negative 5. I'm going to jump over to the, actually, no, I'm just going to keep going. So if you look at C, to solve C, I need to get N by itself. To do that, I have to get rid of that 8. That is a negative 8 times N. The opposite of timesing is dividing. That is not a plus 8 situation. Sometimes people mix that up. That is negative 8 times N because there's nothing in between the 8 and the N. The opposite of timesing is dividing. So I actually have to divide both sides by negative 8. The negative 8's will cancel on the left. When I divide the right side by negative 8, I get an answer of N equals 9. Negative divided by negative is a positive. For D, I have the same situation, so that negative 9 needs to be divided to both sides. When I do that, I get M equals, I believe it's negative 0.5. Yeah, I knew that. Negative 0.5. Awesome. If you look at E, the way that E is written right now, that is K divided by 6 equals 5. So if I want to get the K by itself, I need to get rid of this divide by 6. The opposite of dividing is multiplying. So I need to multiply both sides by 6. On the left-hand side, those 6's would cancel out, and I would only have a K left over. And then 5 times 6 is 30, giving me an answer of K equals 30. If I look at F, that's the same situation. So I have H divided by 2. That's a divided by symbol. The opposite of division is multiplication, so I have to multiply both sides by 2. On the left, the 2's would cancel. On the right, on the left, I'd be left with only H. On the right, 1.6 times 2 would be 3.2. That means H equals 3.2. Awesome. For G, that is A divided by negative 7. The opposite of divide is timesing. So I need to multiply both sides by negative 7. On the left hand, that will cancel out, leaving me with only A equals 8 times 7 is 56. A positive times a negative means it's negative 56. So my answer is A equals negative 56. Wonderful. We'll do one more like that, and then we'll get into some that are a little bit trickier. So H over here, that's W divided by negative 4. The opposite of divide is multiply. So I'm going to multiply both sides by negative 4. On the left, that will cancel. I will be left with just w equals, on the right-hand side, a negative times a negative is going to be a positive, and 1.1 times 4 is going to be 4.4. W equals 4.4. Awesome. I. Um, I is a tricky one. The reason why I is a tricky one is because your letter or your variable is in the denominator. That means it's on the bottom of the equation. The mistake people make is what they do is they try to divide both sides by 20. And this is a mistake, so don't write this down. But what they do is they say, well, I'll just divide by 20, because then the 20s will cancel. And then on the left side, people say, all I'm left with is x. And on the right side, 5 divided by 20 is 0.25. But this is actually incorrect. The reason why is because this x is in the denominator, meaning that when you divided both sides by 20, you weren't left with only x. You were left with 1 over x. And that does not count as having x by itself or isolating the variable. So instead, what we do is we realize the variable is in the denominator, and we need to get that variable off the denominator. The way that we do that is by multiplying both sides by x, like that. This will cancel the x's on the left, and it'll move the x's to the right side, giving me a new equation of 20 equals 5x. And now our variable is no longer in the denominator, and this goes back to being a question that I can solve. If I want to get x by itself, it is now attached to that 5, meaning I have to divide both sides by 5 to cancel those out. This gives me 4 equals x as my final answer. And we're going to see that again. So if we look at J here, I'm trying to solve for x. I notice that x is in the denominator, meaning the bottom of a fraction. So I need to get it to the top. The way that I move it is by multiplying both sides by x, because this will cancel the x's on the left side, leaving me with only negative 36. And on the right side, I now have negative 12 times x, so negative 12x. So when I see that letter on the denominator, I move it to the other side. I then divide both sides by negative 12. Negative 36 divided by negative 12 is positive 3. So x equals positive 3. Sorry that on the right it says w. It should say x. Awesome. K. There's a couple different ways to do K. I'll show you the two different ways to do it. So the way that I would like you to visualize this is the first thing that I want to do is get rid of the divide by 8. So I'm going to do that by multiplying both sides by 8. That'll cancel the 8's on the left, leaving me with 5n on the left, equals 40 times 8, leaves you with 320. Then I would like to get rid of the 5 by dividing both sides by 5, leaving me with n equals 320 divided by 5 is 64. That's how I like to do it. Now, there is another way. So the other way you could do it is this 5 over 8n equals 40. I could treat that 5 over 8 as just one coefficient, like treat it as a number, which means that if I wanted to get rid of this entire fraction, the opposite operation would be division, because that entire fraction is being multiplied by n. So I would have to divide by 5 over 8. And what I do to one side, I would have to do to the other. This would give me this situation. N equals 40 divided by 5 over 8. If you put this in your calculator, what's important is that the 5 over 8, you either change it into a decimal and then you do 40 divided by that decimal, or you put brackets around the 5/8 so that your calculator knows to do 40 divided by the fraction 5/8. If you put this in your calculator, you should get that n equals 64 still. The problem with doing it the second way is that your calculator often makes a mistake right there. When you try to put that in your calculator, it makes an error. It doesn't get 64. It makes some sort of mistake. So that's why I don't like that method, and I much prefer the first method. I got rid of the 8, and then I got rid of the 5, and I treated them separately. Awesome. We look at L. We're going to do this only one way, the way that I prefer. So I want to get A by itself. The first thing I realize is that there's a divide by 3. The way I get rid of a divided by 3 is by multiplying both sides by 3. This leaves me with 4A on the left equals 2.4 times 3 equals 7.2. Then I need to get rid of the 4 by dividing both sides by 4. That will leave me with a final answer of A equals 1.8. Awesome. That's how to get rid of things that are being multiplied and divided. If we look, we have some algebra tiles to kind of do the same thing. So we look at this first one. If we were to think of this as an actual algebraic equation, this is 2x's, right? There's an x and an x equals, and then there's 6 individual ones. Again, like you could look at this different ways. The way I like to look at algebra tiles like this, I'm trying to figure out the value of 1x. So since I have 2 x's here, I'm going to try to break the second side up into 2 groups. So that would be one group, and this would be the second group, and those are equal. And then I can equate each one of these to a value of x. So I can see that x must equal 3 for this to be true. So that means my answer is x equals 3. That's the same thing as if we went in algebraically, we divided both sides by 2. 6 divided by 2 is 3, so x equals 3. Same idea, just algebra tiles. Some people prefer the algebra tiles. Awesome. If we look at this one, we can do the same idea. I have 3 x's on the left. I want to break this right side up into groups of 3. I have 6, 12, 18, 19, 20, 21. So if I broke these up into groups, I would have one group right there. I'd have another group. Let's see. 1, 2, 3, 4, 5, 6, 7. I think that would be a group right there. And then another group right here. I've broken these up into 3 equal groups, which means they all kind of match up. Oh, I did the wrong color there. Right? That's one x there. That's a second x there. That's another x there. That means x must equal -7. Just like a visual way to do it. Algebraically, this would be 3x equals -21. Divide both sides by 3. And I get x equals -7. A reminder that we won't do a lot of algebra tiles on tests and stuff like that. So if you're stressing about algebra tiles, it's okay. The algebra is far more important. And moving forward, grade 10, you barely even see algebra tiles. Grade 11 and 12, you never see them again. So the algebra is definitely more important. The algebra tiles are just supplementary, basically, to help you try to understand what's going on if you're just more of a visual learner. Okay. Word problems. So with word problems, our goal is going to be to try to turn the words into an equation and then solve the equation. When we do that, we build the equation slowly. So as we read the equation, we're going to try to build it. It says the sum. Sum means I have addition. The sum of a number. I don't know what that number is, so I call it x. So the sum of a number, x, and 35, there we go. That represents the sum of a number and 35, x plus 35. Is key. Is means that's where your equal sign goes. And the last thing we have is 98. That equation means the sum of a number and 35 is 98. And I just built it into equation by going very slow. I then can figure out what that number is by doing opposite operations. If I minus 35 from both sides, I end up getting 98 minus 35 is 63. That means the value of that number is 63. That's my advice. So when you get these word problems, build the equation slowly, like as you read the question, and then try to solve the equation. Don't read the whole question at once. Otherwise, it's very overwhelming and confusing. So we'll try again with this one. It says the difference. Difference means subtraction. So I have a subtraction question. Of a number. I don't know what that number is, so I say x. And 18. That's the second number. I now have the difference of a number and 18. Is means put an equal sign, and then 35 is your last thing. So we built that equation by going slow. Difference means subtraction. Of a number is x, and 18, I put 18 in. Is means equals 35. My goal here is to get 18 to the other side, so I add 18 because that's the opposite of subtract. And I end up getting that x equals 53. Awesome. Maybe I could see. Build it as you read it. 23 plus. 23 plus. There we go. 23 plus. A number. I don't know what the number is. I put x. Is means equals 42. My goal here is to get x by itself. The 23 is an invisible plus 23. So the opposite of adding that 23 would be subtracting that 23. So we're going to subtract 23 from both sides. Leaves me with x equals 19. Awesome. Next one. 45 decreased by. That means I have 45 subtract. That's what decreased by would be. It's subtracting something. So 45 decreased by a number. We don't know, so we put x. Is means I now put an equal sign. 21. And I have 45 minus x is 21. This is a tricky one. So a lot of people will mess this up because they'll try to move that 45 by adding it because they see that subtraction sign in between the two and it messes them up. What you have to imagine is this is an invisible plus 45. And to move a plus 45, I actually subtract 45. This negative sign in front of the x is actually a negative 1 timesing the x. So I move the 45 over and I do it to both sides like that. And I'm left with negative x equals 21 minus 45, which is negative 24. I now have this invisible negative 1 timesing by x. The way I get rid of that is by dividing both sides by negative 1. That leaves me with x equals positive 24. Because those negative 1s would cancel on the left, and then negative divided by negative becomes a positive. Awesome. We have 4 left. If you look at E, I'm going to build it as I read it. 6 times, so that means 6 times a number. I don't know what the number is, so I put x. Is means equals negative 96. I have 6x equals negative 96. The way I would get rid of that 6 is by dividing both sides by 6. Negative 96 divided by 6. Throw it in your calculator, and you get x equals negative 16. Awesome. F. Negative 12 times. So negative 12 times a number, that's x, is means equals negative 84. To solve that, I'm going to divide both sides by negative 12. On the left-hand side, the negative 12s will cancel out, and I'm left with x equals negative 84 divided by negative 12, should be positive, and it's positive 7. Awesome. G, half. That's a tricky one. Half means to divide by 2. Right? So half of a number, so divide by 2 a number, means equals negative 9. That's a tricky one. So half of a number means you have something divided by 2. To get that x by itself, I'm going to multiply both sides by 2, so the 2's cancel, and I'm left with x equals negative 18. Awesome. The last one. 36 divided by, so I have 36 divided by a number, so 36 divided by x, means equals 12. This is one of those tricky ones where I'm going to have to actually multiply x to the other side because I don't like having x in my denominator. That gives me 36 equals 12x, and then I can divide both sides by 12, leaving me with 3 equals x. Wonderful. That's solving one-step equations. In the future, we'll be doing two-step equations. You're definitely going to want to get good at one step before you try moving on to the harder ones.